Everyone says the AI bubble is bursting because the hype got ahead of the money. That is the comforting version. The more dangerous version is this. The money is still there, but the physical world is pushing back. Half of major U.S. data center projects are now delayed or quietly canceled in key hubs. Not because Silicon Valley ran out of ambition, because the grid cannot hand over enough power fast enough. AI was sold as limitless software. The first real limit turned out to be electricity.
That is why the biggest software companies suddenly look like energy companies. Amazon, Google, Meta, and Microsoft were reported to be spending close to $400 billion a year in the United States, much of it on the infrastructure needed to run AI. The awkward detail is that current AI revenue remains tiny beside that spending. So this is not a normal product cycle. It is an infrastructure land grab. The companies that win are not just trying to build better chatbots. They are trying to secure the power supply beneath the entire AI economy.
Then came Stargate, OpenAI, Oracle, and SoftBank promising nearly $500 billion for new data centers across Texas, New Mexico, Ohio, and the Midwest. Sam Altman described historic progress. Globally, AI-focused companies are expected to pour trillions into building and upgrading data centers over the next 5 years. But every one of those promises depends on boring physical things: land, transformers, substations, cooling systems, water, permits, and power contracts. The pitch is futuristic. The bottleneck is brutally old-fashioned.
The United States already hosts the largest share of the world's data centers, roughly 4,000 out of nearly 11,000 active facilities. Running those buildings is already energy-intensive. Cooling the biggest hyperscale sites can consume millions of gallons of water a day. But water is only part of the pressure. In Northern Virginia's data center alley, projects are slowing because the grid is struggling to keep up. Public approval has collapsed too, from 69% in 2023 to 35% among Virginia voters. The backlash is no longer theoretical. Before a new data center can even plug in, utilities have to study whether nearby lines, substations, and transformers can handle the load. Those studies can cost millions and take years. That means the future of AI can get stuck in a connection queue before a single server is switched on. And the cost does not stay inside a corporate spreadsheet. When data centers bid up electricity demand, communities can feel it through higher bills, strained infrastructure, and political fights over who gets priority when power is scarce.
The scale of the queue is staggering. Lawrence Berkeley National Laboratory reports about 2,600 gigawatts of proposed generation and storage waiting for connection. That is roughly twice the size of the current U.S. power system. Some new data centers could need 50 to 100 times the electricity used by the Empire State Building. The largest projects under construction could collectively demand as much power as Italy. This is the clearest sign that AI's limiting factor is not imagination. It is the grid beneath our feet.
The physics starts with something that feels tiny: a prompt. A single complex AI query can use far more energy than a normal web search. One comparison puts it near the electricity of an LED light left on for about 20 minutes. The exact number varies, but the direction is what matters. ChatGPT is not handling thousands of requests, it is handling billions. The United States alone saw hundreds of millions of ChatGPT queries per day in 2025. One prompt is small. Billions of prompts become infrastructure.
And adoption is still early. More than 1 billion people already use AI, while billions more have not made it part of daily life yet. Companies are racing ahead even faster, with reports showing most global firms already integrating AI in some form. If adoption keeps climbing, Goldman Sachs research projects data center power demand could rise 160% by 2030. That is like adding another Germany to the global energy grid in only 6 years. The bubble is not just financial, it is electrical.
The obvious answer is renewables, and the grid is trying.
New interconnection applications surged in 2023, with most proposed capacity coming from solar, wind, and battery storage. But AI workloads need constant power. The wind slows, the sun disappears. Even in strong solar regions, usable sunlight may cover less than half the hours in a year. Renewables matter, but they do not remove the central problem. AI wants electricity all day, every day, at massive scale. Intermittent power makes the race harder, not impossible. This creates scarcity, and scarcity changes the market. The biggest tech firms are already signing power deals with utilities across the United States. They will get priority because they can pay, plan, and commit at a scale smaller companies cannot match. Venture-backed startups may raise money and promise disruption, but they still need compute. If power is scarce, GPU access gets more expensive, model access gets limited, and the smallest players feel every shortage first. The grid becomes an invisible competitive moat. That is why the real AI cleansing may not kill AI. It may kill the weak business models around it. Investors are already losing patience with generic chatbots and gimmicks. Capital is moving toward specialized systems that write code, detect fraud, optimize logistics, perform medical analysis, and lift profit margins. Those tools may be valuable, but the companies building them still need access to the same concentrated compute infrastructure. In a gold rush, the safest fortune often belongs to whoever controls the tools, the land, and now the electricity. For years, the loudest fear was rogue AI ending the world. The more immediate danger is less cinematic, a handful of companies owning the infrastructure everyone else needs. To protect that position, big tech cannot rely only on public grids. It is moving toward dedicated energy. The clearest example is Microsoft and 3 Mile Island, a nuclear site forever linked to the 1979 accident. One reactor was permanently shut down. Another closed in 2019 because it was not profitable. Now AI demand may bring it back. Microsoft's 20-year agreement is designed to secure 835 megawatts of electricity for the grid, supporting its planned data centers. That is enough power for roughly 800,000 American homes. But in this case, the point is not household appliances. It is AI infrastructure. The catch is huge. A fully shut U.S. nuclear plant has never simply been restarted into a new commercial life. Permits, safety reviews, grid integration, economics, and public trust all stand between the press release and actual electricity. Meta found out that even enormous money can run into tiny obstacles. Its plan for a data center near an existing nuclear facility was reportedly blocked by a rare bee species living on the site. The detail sounds absurd, but it reveals something serious. AI infrastructure is not built in a spreadsheet. It is built on land, inside ecosystems, near communities, and under environmental rules. Then Amazon made its own nuclear-adjacent move, a $650 million deal near Pennsylvania's Susquehanna plant. Amazon's Pennsylvania deal could eventually deliver almost double the power needed by the city of Pittsburgh. But regulators pushed back. The Federal Energy Regulatory Commission blocked Amazon from taking power directly from a nuclear plant for a hyperscale data center, warning that diverting so much electricity could threaten local reliability. The deeper issue is simple. When AI competes with communities for power, someone has to decide who goes first. And if everyone keeps the lights on, someone still pays the higher bill. Google is betting on small modular reactors, or SMRs, as another way out. In theory, they are smaller, cheaper, and safer to deploy than traditional reactors. In practice, commercial viability is still uncertain. Designs are not proven at scale, and the Nuclear Regulatory Commission does not wave projects through because the technology sounds promising. Google wants nuclear-powered data centers by 2030. The politics may be favorable. The engineering and approvals are still the hard part. The global race makes the pressure sharper. The United States wants commercial SMRs operating by 2030, but it does not yet have new commercial units in service. China and Russia already have working examples. Even if American tech companies eventually get their reactors, they will not solve AI's entire power appetite alone. They will change who has priority, who has leverage, and who can afford to build at frontier scale. Nuclear is not the end of the story. It is the next board on the game.
This is where the story stops being about data centers and starts being about power itself. Tech companies are no longer just building productivity tools, search engines, or social apps. They are trying to become operators of critical infrastructure. Once a private company controls compute, long-term energy contracts, and access to frontier models, it becomes much harder to treat it like an ordinary software vendor. It starts to look like a utility, a defense contractor, a landlord, and a gatekeeper, all at once.
Not every country can play this game. Many nations do not have abundant power, nuclear capacity, deep capital markets, or grids ready for hyperscale AI. If they want modern AI capability, they may have to rent cloud platforms and compute from foreign firms. That dependence changes sovereignty. It means the most important systems in an economy may run on infrastructure owned somewhere else, priced by someone else, and prioritized by someone else's contracts. The sovereign cloud is not just a technical phrase, it is a geopolitical warning.
That is why tech CEOs are now regular fixtures in the halls of government, consulted on AI policy, national security, infrastructure, and competition. In older eras, hidden power was associated with banks, oil, defense, or intelligence. Now, big tech belongs in the same conversation. Carnegie Europe warned that billionaire tech titans increasingly rival nation-states in influence. The reason is not just that their products are popular. It is that their platforms, clouds, and compute systems are becoming the operating layer beneath economies. But here is the twist. This does not mean AI is useless. The public version may be overhyped, but the quiet business version could be extremely valuable. The next phase is agentic AI. Systems that coordinate tasks, monitor workflows, flag anomalies, and help teams make decisions faster. These tools do not just answer questions, they become invisible machinery inside companies. If the consumer bubble deflates while enterprise AI keeps improving, the winners will be the firms with enough compute to run that invisible machinery at scale. The best agentic systems are already reported to boost efficiency by 30 to 50% in some settings. When something breaks, they can flag the anomaly and pull a human into the loop. The goal is not magic. It is time saved, waste reduced, and decisions improved across enormous operations. Take logistics. Trucks sit empty, routes get delayed, warehouses misallocate inventory. If AI trims even a small percentage of that waste, the savings can reach billions. That is why serious capital keeps showing up.
The logistics market shows the pattern. AI in logistics has grown from billions to even more billions in just a few years, because the value is not a robot replacing every worker. It is a software layer reducing friction across the whole operation. Similar logic applies to fraud detection, cybersecurity, finance, and industrial planning. The most profitable AI may not look dramatic on camera. It may look like fewer delays, fewer errors, better forecasts, and slightly better margins repeated across thousands of decisions every day. Medicine may become another proof point. AI could help scientists understand disease, design better compounds, and run smarter trials. If even part of that promise works, pharmaceutical companies could save years of experimentation and unlock billions in operating profit. But again, the lesson is not that every AI company wins. The lesson is that valuable AI becomes compute-hungry infrastructure. The hype companies may vanish, the serious industrial systems may stay, and the companies that control the compute beneath them become harder to dislodge.
So yes, some data centers may become abandoned monuments to overconfidence. Some AI startups will disappear. Some promises will age badly. But that may not be the end of the boom. It may be the consolidation phase. That is the limitless AI lie. AI was marketed like pure software, floating above the world. In reality, it is becoming one of the largest physical infrastructure projects of the century. The real question is who owns the foundation when the hype is gone. If a handful of companies control the electricity and compute behind intelligence itself, they do not just build the future, they collect rent on everyone else's.